So let's talk about the applications of ideal gas. So we are having a equation of the ideal gas. We were done with the equation. So the equation was P equal to nRT. So this equation is based on the calculation of the molar mass and the calculation on the density. So we are having an equation that is PV is equal to nRT. So here you can say that PV is equal to, here at the number of moles we are having a molar mass. So as you guys all know, molar mass is equal to the given mass upon the molar mass, that is M. So we can write here M upon M like this and RT. Okay, so here you can see that PV M is equal to MRT. Okay, here it's dividing, it will be moving, here it will be getting multiplied, and you can say that we have to find the molar mass. So M will be is equal to the MRT upon PV. So that is the equation of the molar mass. How? Let's see. Here you can see we have to find the molar mass, then PV here is getting multiply, it will be getting here and will be getting divide. So that is the molar mass equation. So here you can see that we have put in the M and upon M because of the, if you, as you guys all know, number of moles is equal to given mass upon molar mass, given mass and molar mass. That's why we have put it M upon M. Here we are having a density, and as you guys all know, density is equal to MV, that is mass per volume. Okay, so that we are having an equation that is PV is equal to nRT, and PV is equal to, we can put here that according to the, here we are having number of moles, but we are finding the density of the ideal gas, or you can say the applications of the ideal gas on the basis of the calculation of the density. So we can write M upon V. Why? Because we are finding the density, and the formula of the density is mass per volume. So here I can write this as 2. So here you can see that we can write PM is equal to dRT. What is D? This is density. Here we have opened the formula, and here we are having a density because it is the formula of the density. So we have written density here. So D is equal to PM upon RT. That is the equation of the, you can say that the application of ideal gas on the calculation of the density. So here we have find it equation that was PV is equal to nRT, which is the equation of the ideal gas, and R is the constant, as you guys all know. But you can say that we are having, for 1 mole of gas we are having an equation that is R is equal to PV upon NT. As you guys all know, in the previous video we are done with these all equation. I'm just giving the overview. But for 1 mole of gas, you can say that to conduct the different experiment, okay, so here R is equal to PV P1 upon V1 upon T1, okay, because of the number 1 experiment. And second, if we are doing the experiment, so we can write P2 V2 upon T2 2. Okay, so here you can see that R is equal to R, so we can write that P1 V1 upon T1 is equal to P2 V2 upon T2. Okay, so this is the gas equation for the experiment. This is the gas equation for the experiment. But without experiment, we are having equation that is PV is equal to nRT. So that was the application of the ideal gas equation.